Brad Williams, Excel Prime. How to calculate depreciation here? We're looking at an accelerated depreciation method as opposed to the straight line. What that means is, let's say we want to double up. We want to increase the depreciation by 2 times or by a formula. Here we're using a variable declining balance or a VDB function. The beauty of this is its flexibility. There's a double declining balance format, and you can use double declining, or you can use this variable declining balance to incorporate the double declining. A little more about this function. Returns the depreciation of an asset for any period you specify, including partial periods, using the double declining balance method or some other method you specify. The syntax is this VDB: cost, salvage, life, start period, end period, factor, no switch. It's pretty much cost required, salvage, if there is salvage, note it. The life, similar to the straight line. The difference here is we have a start period. We can state specifically the start period, the end period, the factor. Optional, the rate at which the balance declines. If factor is omitted, it is assumed to be 2, the double declining balance method. Change factor if you do not want to use the double declining balance method. The no switch, optional. A logical value specifying whether to switch to straight line depreciation when depreciation is greater than the declining balance calculation. If no switch, Excel does not switch to straight line depreciation even when the depreciation is greater than the declining balance calculation. If no switch is false, Excel switches to the straight line depreciation when depreciation is greater than the declining balance calculation. So let's take a look at this VDB. We go up in here to this formula. The first section is going to be almost identical to the straight line, and this back end is going to be a little bit convoluted. But here we have the VDB. Let me just highlight it. We have the cost, C6, which is shown right here, salvage value, which is 0. We have a life start, which is E6 right here, 5 times 2. Then we have a start period. This is where you determine the timelines. If year F5 equals D6, put 0. If year F5 is equal to D6 plus E6, take E6 times 2 minus 1. Otherwise, take year F5 minus D6 times 2 minus 1. The end period is similar. If year F5 is equal to D6, do this. Then you put a 1. If year F5 is equal to D6 plus E6, it's going to copy the same thing. What we're trying to do is look at, that's the start and the end periods. What's this first section? All we're trying to do is determine the start time today. All we're going to do is read up to the VDB. It says if or year F5, same thing, is less than D6, then year F5, or if year F6 is greater than D6 plus E6, put 0, then you're going to do your VDB calculation. It would be 0, and we can't start the formula. We're going to have to wait till 2021 to start depreciation. Otherwise, this first section is true to go ahead and do this calculation. None of Excel's depreciation functions take into account a half year. In other words, if you bought all of your assets on the first day of the year, do you start depreciation immediately? And with this formula, the assumption is you're using half year convention so that only half the depreciation is taken in the first and last years. To accomplish this with the VDB, we have to trick Excel into thinking that the asset has twice its useful life. Also, for an asset with a 5-year useful life, the period for the first year goes from 0 to 1. For the second year, the period span 1 to 3 years. The third year span is 3 to 5. That continues until the last year, which spans 9 to 10. 10 is double the 5-year life. The starting period portion of the formula evaluates to something like this. If the year to complete is the acquisition year, make the starting period 0. If the year to compute is the last year, make the starting period the useful life times 2 and subtract 1. For all other years, subtract the acquisition year from the year to compute, multiply by 2 and subtract by 1. The ending period portion of the formula is similar to starting period portion. For the first period, it ends at period 1. For the last year, it ends at the useful life times 2. For the middle year, it does the same calculation except that it adds 1 instead of subtracting. By doubling the useful life, say from 7 periods to 14 periods for a 7-year asset, we can introduce the half-year convention into a declining balance function like VDB. Brad Williams, XL Prime, thank you.